Okay, all right. So welcome back to Mr. Ng's summer lesson series. All right, lesson 2. So today we're gonna focus on multiplying and dividing integers. So brief overview. When you are multiplying, dividing integers, all you have to do is look at the sign of the numbers. Now, before we go any further, I want to talk to you guys about what we learned so far from last week. So one of the things I want you guys to focus on, right, is when it comes to adding integers and subtracting integers, right? For adding, what's the rule again? Yeah, you need to be able to tell whether the signs are the same or different, right? So one of the things that actually I want to emphasize is when you do any of these questions from now on, you gotta be able to recognize the operation first, because if you don't go out of the way to think about the operation, you wouldn't know which rule to choose from to begin with. And I think a lot of times when people are doing this in the beginning and they are getting it wrong a lot, what they're doing is they are skipping that step. So they're not even thinking about what the operation is. They're relying on what they learned previously. So if they see two numbers and they see add and they forget about the signs, they're just gonna add it. So I'll give you an example. If someone sees this, right, they might not even think, they just think that this is 5, but that's wrong, right? It's no longer applicable the way that it used to be. You actually have to think about the rules, okay? So first step, you need to know what the operation is. And the second step, you need to know what the signs are. Okay, as a matter of fact, why don't I just tell you this now? Does it matter when you are adding what the signs are? Absolutely, right? Because if the signs are the same, there's a set of rules, right? When the signs are the same, what do? Right, you add and then you keep the sign, right? When they're different, what do? Yeah, you have to subtract and then you have to find the sign of the larger number, right? So you see what's happening here. There are 3 levels of decision making here. So whereas for subtract, it doesn't matter, right? Because subtract only has one rule. What's the rule of subtraction? Yeah, keep, change. So in other words, subtraction is actually an addition question. Okay, so that's what subtraction is, and then you have to make the same decision. Are we adding? Yes. Are the signs the same or different? Okay, so that's what that. So this is also why I hope you guys can appreciate the fact that we have to learn how to add before we subtract, because subtraction is just addition. So it refers back to addition. Okay. Now let me tell you the rules for multiplication then. So for multiplication, the rule is this. All right. Again, there's a decision-making tree here. If they're the same signs, what would happen? And if they're different signs, what would happen? Now, it's the same for divide. So today's lesson is maybe considerably easier than last week's lesson. All right, because it's the exact same decision-making tree for multiply and divide. So what I mean by that, so okay, if they're the same signs, the answer is always positive. All right, if the signs are different, the answer is always negative. So let me give you 2 examples. Okay, and these, again, you're gonna have to more or less remember this. Okay, by the way, so this is our 3rd decision making level. So let me give you an example. If you use, right, so let's say you have a positive times a positive. So let's say you have, so a positive, hold on, what am I doing here? So you have a positive times a positive. So okay, let's do this. Positive times a positive. The answer is always positive. All right? Or a negative times a negative, the answer is always positive. So a negative times a negative would be a positive. All right. Now, when the signs are different, what I mean by that. So if you have a negative times a positive, the answer is always a negative. If you have a positive, let's switch it around, right? If we have a positive times a negative, the answer is still a negative. Okay, so that's the rule. So why don't you guys go write that down? Again, before we move on, again, right? There are 3 levels of decision making here. One, what's even the operation here? Are we gonna add, subtract, multiply, divide? And then it will take you to level 2. Now you gotta think, okay, all right, which you have to analyze the signs, right? Notice, right? For all of these, pretty much, you have to know whether the signs are the same or different, because that itself tells you what rule to use on level 3, right? So again, right, if you add the same signs, what do? You add them, keep the sign. If you add with different signs, what do? Right, you subtract, you keep the sign of the larger number, right? When you subtract, what's the rule? Keep, change, which means you're doing addition over again. When you multiply, what decisions do you have to make? Right, are they the same signs or different signs? What do you do when you multiply with the same signs? The answer always, so you multiply them and the answer is always positive. What happens when you multiply numbers with different signs? So for example, positive times a negative. Yep, the answer always comes out negative after you multiply them. Same thing with division, right? You divide, so on and so forth. Okay, so let's take a look at some examples. Is this it? Yep. All right, so if you want, you can write this down, press pause and write this down. Multiplying, dividing integers, same signs versus different signs. Okay, so this is the rule. If you want to, why don't you write this down? Okay, so press pause right now while I read, or you can copy it while I read it. All right, let's see. When you're multiplying or dividing integers, let me use that. I like this blue. It's a good blue color. All right, so let's see. When you are multiplying or dividing integers, same signs, positive answer always. No exception. All right? When you multiply with different signs, it's going to be a negative answer always. No exception. So let's use numeric examples. I think that might be better. So 2 times 2. Now again, I'm not trying to insult your intelligence. I'm just trying to prove a point, right? Because your thinking from now on till, I don't know, the rest of your life, you're gonna have to think differently when you think about adding, subtracting, multiplying, dividing with numbers. Okay, because now we're involving signs. So now we multiply them first. 2 times 2 is 4, right? Are the signs the same or different? Yeah, right, same signs, right? Why? Because they're both positive. So the answer is positive 4. Likewise, if you do 2 times 2 here is 4. Negative times negative, same sign. The answer always comes out positive. Okay, got that? Right? Okay. Now, different signs. When the signs are different, you multiply them. But since the signs are different, right? You know why they're different, right? This is positive, that's negative. The answer comes out negative, always. Lastly, 2 times 2, that's 4. But this thing has 2 different signs, right? This question has 2 different signs, so the answer comes out negative. Okay, that's it. That's how you do it. All right, that's it. Now again, you're just gonna have to know these rules. Now in class, back in the day, like last year, we actually play a game in class like over the course of like a week, and by the end, everyone knows what the rules are. And obviously, you know, we can't do the same right now. So that's why. Okay, so you're gonna have to study these on your own. All right, I cannot transfer the data or the rules, all right, directly to your brain. All right, it doesn't work like that. So you're gonna have to do the studying on your own. Now, okay. Now let's practice then. All right. Nah, I don't want to show you this actually. You know what? Okay, you know what? Actually, let's do this. And then at the end, if you want some challenging questions, I will show you adding and subtracting with signed fractions. All right, that's a lot of fun. And yeah, okay, let's try that. Now, let's see, how should we go about this? You know what? Let me pick 2 questions. Oh, more than 2. 1. Oh, I really like this one. This one's good. I think this one's good. All right, 1, 2. Let's pick 1 more. Actually, that's sufficient. Actually, you know what? That is good enough. Actually, yeah. Okay. Now, before we move on, all right. I think everyone here recognizes that that's a multiplication sign, right? What operation is this? With a number right next to another number in a parentheses. That's multiplication too. So, for example, like, right, like that's what that is, right? So this is 7 times -3, and you will recognize why they would use a parentheses, right? Because there's a negative sign here. The dot here, right, means multiply. This means this multiplied by this multiplied by that, right? I'm just double checking here. And this bar here means what? Yeah, division, right? Okay, all right. Let's try these 2, and then I'll give you some time to practice the rest on your own. All right. So here we have 7 times -3. So what's the operation here? Right, multiplication. Same signs or different signs? Different signs. So the answer always comes out different signs. What do the sign always come out as? Yeah, negative. Okay? All right. Now, this we talked about in class early on in the year already. What does this mean? -5 in parentheses and then with a little 2 on the top, right? This superscript. What does that mean? Yeah, it's an exponent. So what does that mean? It means that number multiplied by itself. Okay, got that? So -5 times -5, what would that be? We're multiplying, right? Are the signs the same or different? Yeah, the same. So the answer comes out as, right, positive. Okay, now I want to try, I think we need to do 14 actually. But that's the only question like that though. All right, we got to try 14. Okay, all right. So now we're going to go left to right, right? Remember with, even though multiplication is commutative, right? But in the order of operations, it wants you to go left to right. I think that's still a good practice. So now here we got 3 things going on. So we got to do them one at a time. So let's do this first. 4 times -2, what's the operation? Right, multiply, right? Was 4 times 2. That's 8. Are the signs the same or different? Different. So the answer always comes out as, right, negative. So I'm going to multiply this by -3. All right, because this is done, right? So now I got to do the last step. So again, what's the operation here? Right, multiply. Are they the same signs or different signs? Same signs. The answer always comes out, right, positive, right? Positive 24. Okay, good. Okay, so press pause right now. Yeah, today's lesson is going to be short. That's good, because last week's lesson was unbelievably long. So press pause right now. And when you come back, I will give you some of the answers, and then some of them I want to go over with you. Okay? So press pause right now. Okay, all right, and we're back. So I used a slightly different sort of green. I really like these like very summery colors. It makes me happy when I see these colors. All right, so yep, the ones in like a green. The answers now. I left 13 alone on purpose because this is what 13 is. 13 means this, all right, and it would be a good idea for you to write it out. This is number 13. -3 times -3 times -3. A number, so you see the 3 here, the exponent of 3, right? That means the number multiplies by itself 3 times. Now we got to take steps here, all right? So this is -3 times -3. So here we're multiplying. What are the signs? Are the signs the same or different? Same, right? They're both negative. What's negative times negative? Right, positive. and then I gotta do the last step. Again, we're multiplying. Are the signs the same or different? Right, they're different. So the answer is always going to be negative. See that? That's how you do it. Okay, so that's the lesson. If you want to consolidate the information you've learned the last 2 weeks, I could suggest that you go online and find worksheets on this. Is you can Google search this. Signed integers worksheet, and then if you want a PDF version that you can print out very easily, you can type in PDF. Okay, and then you could print it out and work on it. It would be nice if you can find one with the answer key also, you know, just something you could check. So again, I can't say enough. All right, I would say if you were to do 20 questions, let me think. If you can do it within 2 minutes, you've completely mastered the subject. All right, now if they're all incorrect, then no, you've not mastered the subject. But if you get like 15 or more correct, it shouldn't even be 15. I'm really thinking 18 actually. All right, if you get more than 18 correct, then like that tells me that you know what you're doing. Okay, so time yourself actually. So use that timer in your cell phone. All right, find 20 questions. If it takes you 2 minutes and you get more than 18 questions, 17, 18 questions correct, then like you got this subject. Okay, that's good. All right, and then in the 7th grade, I think in the 3rd unit of the 7th grade, your teachers are going to go over this again. And that's good because now you have a head start. Okay, so that's important. All right, now if you want to stop right now at the 17-minute mark, you can. But what I'm going to do right now is for the students who would like more practice, all right, with more difficult questions. So now we're gonna start with this. Now I need to get some water. Hold on, let me press pause. All right, and I'm back. So before we start, while I was drinking some water, I was also thinking that the way you should approach this when you do positive and negative numbers and things like that is you have to approach it as if something that's, you have to achieve a level of routine with this. Meaning, like, just as you guys can use the multiplication table without thinking about it much anymore, doing this should be like putting on like, or tying your shoelaces. All right, it should be second nature. It should be like it should be like as simple as doing something like that. Okay, where you don't really need to think about it anymore. Okay, so that's what I want to emphasize. When you can get to that point, that means you know what you're doing. Really. Okay. All right. So let's talk fractions now. I'm going to keep it simple here. So here we're going to evaluate each expression. Okay, to solve. All right. Now, remember with fractions, right? If the denominators are the same, you keep the denominators and you add the numerator. Right? I'm just reviewing very quickly. So here now, so this is where it gets interesting. Is if you really know what you're doing, then over the course of time, you can solve fractions with sign numbers too. Like that's what we're looking at, and that's why I'm showing you this. Now, I kept it simple, all right, at first, because I kept the denominators the same, because I want you to just think about, I want you to take one step at a time. Now, let's start, okay? Let's do a couple of examples together, and then maybe I'll show you the answer key, okay? All right, so let's try these. Now, here, first of all, don't even look at the fractions. Look at the operation. What operation is that? Yep, that's subtract. What's the rule when you subtract? Yep, keep, change. All right, so I'm gonna rewrite, okay? That's what every good student does. So keep, change. Now I gotta change that to a positive. Okay, so far so good, right? Nothing crazy here, right? Now, look at this. Now what operation is this? Yeah, this is adding. So what's your decision-making tree here? Yep, same signs or different signs. So these have the same signs or different signs? Different signs. So what do you do when you're adding with different signs? Yep, you subtract them, keep the sign of the larger number. And there you have it. That's the answer. Okay? Not too bad, right? Okay, let's try another one. All right, let's see. Let's do 2 of these together, and then I can let you practice. Now, for number 2, what's the operation here? Okay, again, this should be your thinking, decision-making tree here. Are you adding, subtracting, or multiplying or dividing? Yep, you're adding, right? So what do you do when you're adding with same signs or different signs? Different signs. So when you're adding with different signs, what do? Yep, you subtract them, and then you keep the sign of the larger number, positive. Now this is 1, right? So see that? Okay, so right now, yeah, all you have to do is do these next 6. So press pause right now and do number 3 to 8, and when you come back, I will have the answer key for you. So press pause right now. Okay, all right, and we're back. So, yep, here are the answers for 3, 4, 5, and 6. The only thing I would mention is if you have an improper fraction, you can leave it as an improper fraction, or you can turn it into a mixed number, all right? However, the following is non-negotiable. You have to reduce, okay? But you have to reduce. Where else? Is this called? No, this is, yeah, this is reducing, kind of. All right. And I also want to point your attention into number 5. All right. There's a name for this. When you have a positive number and a negative number, that's actually the same number, right? You see that? We call that canceling out also. So as you can see, like there's a lot of terms in math that's canceling out. Like they cancel each other out. Think of it like that. Okay, right? When you reduce, right, you're canceling, right? You can cross cancel when you multiply fractions, so on and so forth. Okay, there's even when you solve an equation, right, you can cancel out, right? So there's a lot of that going on. Now, let me move on then. Okay, so if you're still checking your answers, press pause, but otherwise I'm going to move on. Here we go. Now, I want to do, let me see. All right, let's see if I can make this happen. I'll do 1 and 2, and I'll let you guys try 3, 4, and 5. All right, if you're up to it. All right, okay. So here now, different denominators. What's the rule when you have to add or subtract with different denominators? Right, LCM, right, or least common denominator. So what's the least common denominator between 4 and 6? Yeah, it's 12, right? So we can do that. 4 times what gives you 12 times 3, right? So 3 times 3 is 9, 6 times 2, so that's 14. Now, we're adding same signs or different signs? Yep, same signs. So what do you do when you add with the same signs? You add them, and then you keep the sign. All right, what is that? 1 and 11 twelfths, right? So, now, with all of this, why am I even bothering with fractions? Right, and the reason is because like if you can do fractions with positive and negative numbers, then that means you could do fractions with whole numbers. You know what I'm saying? So that's why I keep adding layers of complexity to the work that you're doing, so that you can really like get the practice. Now, the other thing I want to mention is don't get intimidated by questions like 2, 3, or 4, right? Because sometimes when people see the signs, they get like what? They get kind of confused, and then they start worrying, and then they start making mistakes, right? Don't do that. Never get intimidated by the numbers. Always worry about the rules first. If you can, because I trust that you guys can handle the fractions, all right? Because we spent like a month at the beginning of the year doing that. Now the challenge is, can you deal with the signs? Okay, so don't get intimidated by that. Okay, just take your time and do your steps slowly. Okay, now let's see. Okay, worry about the denominators first. So I'm going to start writing up here. What's the common denominator between 8 and 12? All right, take some time if you need to. What's the LCD or LCM between 8 and 12? Now, by the way, this is how you find out, right? So this is a blast from the past. So you do multiples, right? 8, 16, 24, 32, so on and so forth, right? 12, 24, 36, 48, so on and so forth, right? And you'll see that it's 24. All right, if you need to do that, I have a lesson. Remember, I did a lesson on probably LCM, right? So if you want to go back to the playlist with all the tutoring videos, you can. All right, now don't forget about the sign here. 8 times 3, so 5 times 3 is 15. All right, 12 times 2, so that's 22. Now, all I'm doing right now is rewriting. I didn't really change anything. Okay, now what's the operation here? Yep, adding, right? Same signs or different signs? Different signs. What do you do when you're adding with different signs? Right, subtract them, keep the sign of the larger number. And that's it. Okay, that's how you do it. It's not that tough. All right, now that said, by the way, man, let's see. Okay, so before I let you try 3, 4, and 5, I just want to say, if you see a negative sign right outside of this, there's an invisible one here. I think we mentioned this like some other topic early in the year. So that means multiply. Okay, so what does that mean? What is negative times negative? Yeah, positive. So this is, if you were to rewrite this is positive 1/8, right? Remember when you have negative times a negative, when you multiply with the same signs, answer is always positive, right? Like this. That's actually the question. Okay, so it's not as difficult as you would think. Now, the denominators are very tough to find because I remember doing this with the 6th graders last year, and it took everyone a very long time to find the denominators. So when in doubt, actually, you know what you could do is you could just multiply the denominators. Okay, you can do that. All right, so press pause, and when we come back, you know what? Let's do them one at a time. When we come back, I'll go with 3, and I'll give you time for 4, and I'll give you time for 5. Okay? All right? How about that? Okay. All right. So press pause right now, and then I'll come back with the answer for 3. All right. I decided to go over each one with you guys. So the denominator is 350. All right. I know this is going to take a lot of time, but I think it's ultimately, if you have the time, this is good practice. All right. So that's 60. That's 7, right? That's 77. Am I right? 5 times 7, 7, right? Okay. Now, what does that mean? Now we're actually doing the work, right? Because all of this stuff is just finding equivalent fractions. So what's the operation here? Subtract, right? What's the rule when you subtract? Yep. Keep, change, change. So keep that. Change this to addition. Change this to a positive. Now, these questions, they're excellent, actually. It's just the denominators are like, I think the denominators are too big. Sometimes that defeats the purpose. So let's see now. We're adding, right? What's the rule when you add, right? Same signs or different signs? Different signs. So what do you do when you're adding with different signs? Right, you subtract and keep the sign of the larger number, which is positive. Okay, all right. Okay, by the way, if you don't understand this, you could rewind and, you could slow down the video and, see how I did that. Okay, so go ahead and try number 4 right now. When you come back, I will go over the answer with you. So press pause right now. Okay, all right, so again, all right, the tough work here is finding the common denominator, which is 72 actually. All right, I keep thinking that it was going to be much larger than 72, but I guess not. So this is 8, so all these have to have 72. So let's see, 8 times 9, so that's 9, right? 6 times 12, so 7 times 12, 84, right? 7 times 12, right? Let's see, 6 times 12, yep, 7 times 12, yep, 84, okay. 9 times 8, 85 is 40, yeah. Now, here we have subtraction, so what's the rule? Now, you can only do one at a time. You can't solve all three at once, so let's focus on this one here. All right, so keep, change, right? Now, you see how 9 can subtract 84? So I know what you're thinking, you know, like you thought you were going to do just a bigger number subtracting a smaller number, but then it would be a very good question. So let's see, keep, so again, I'm just rewriting this. Keep, change, right? So what's that? So, okay, so we're adding with different signs. What's the rule when you add with different signs? Right, you subtract them, keep the sign of the larger number. So that's this. Now I'm gonna rewrite the whole thing down here. Minus 40 over 72. All right, let's see. Let me double check. I'm just double checking this math here. Yeah, I'm right. Okay, all right. So, and then I brought this down, right? Okay, looks like we're subtracting again. Keep, change. So, keep, change. Now, this changes to a negative. Okay? Now, we're adding same signs or different signs? Different signs. So, adding, no, same signs. Adding with the same signs, what do? Right, you add them, which is what, 115, and then keep the sign. Okay? All right, now last one, between 8, 12, and 16. So press pause right now, and then we can go over it. All right, you know what's crazy is the fact that when I look at these, I keep thinking that the denominators are going to be so large, but they're not. Like, look, this is 48, right? So 8 times 6, so 6, 3 is 18. 12 times 4, 7, 4 is 28. 16 times 3, right? Yeah, so that's 3. Let's go on. Keep, change. I'll go a little faster this time. All right, again, right? Change. The signs are different. What do you do when you're adding with different signs? Right, subtract. Keep the sign of the larger number. And then I got this. What do you do again? Keep, change. Adding with same signs or different signs? Yeah, different signs, right? So I'm going to add them, keep the sign, and that's it. Okay, all right. Okay, I thought it was going to be tougher than this, but I guess not. Okay, all right, let's stop here. All right, thanks for watching. And next lesson, we are going to talk about statistics, mean, median, mode, range. All right, so fairly interesting topic. All right, thanks for watching. Have a good day. And I will talk to you guys next week. Okay, all right, bye-bye.
OMG, that was so good.